NASA's James Webb Space Telescope will capture more stars at higher resolutions than the other space telescopes before it. This will mean a great deal for the field of astronomy. The combination of high-resolution and infrared detecting instruments on NASA's upcoming James Webb Space Telescope will reveal stars that are currently hidden even from the powerful Hubble Space Telescope. The wealth of additional star data and information will allow astronomers to investigate a range of questions, from the birth of stars to the passing of stars to the universe's elusive expansion rate. Early observations with the James Webb Space Telescope will demonstrate its ability to distinguish the individual light of stars in the local universe in a range of environments and provide astronomers with tools for making the most of Webb's most powerful capabilities. NASA's Hubble and Spitzer space telescopes have been quite transformative. They have opened opportunities to the infrared universe beyond the realm of red visible light. The James Webb Space Telescope is a natural evolution of those missions, combining Spitzer's view of the infrared universe with Hubble's sensitivity and resolution. Webb's ability to resolve individual stars that are shrouded behind gas and dust in visible light will be applicable to many areas of astronomical research. The goals of this ERS program are to demonstrate Webb's capabilities in the local universe and create free open source data analysis programs for astronomers to make the best use of the observatory as quickly as is possible. Data from the ERS programs will be available to other astronomers immediately and archived for future research via the Barbara A. Mikulski Archive for Space Telescopes. Webb's ability to pick out details for more individual stars than we have seen before will improve distance measurements to nearby galaxies. This will be crucial to one of the largest mysteries of modern-day astronomy. How fast is the universe expanding? This is a phenomenon called dark energy, and it seems to be the driving force for the expansion of the universe. Various methods for calculating the expansion rate have resulted in different answers. Discrepancies astronomers hope the James Webb Space Telescope's data will help to reconcile. In order to do any of this science, however, calculating distances and then the universe's expansion rate, we need to be able to extract the light of individual stars from Webb's images. The ERS program team will develop software that will empower the community to make those types of measurements. Seeing more stars will mean more insight into the life cycle of these universe objects. Webb will provide new views of the full range of stages in a star's life, from formation to its passing. At the moment, they are quite effectively limited to studying star formation in their own Milky Way galaxy. But with Webb's infrared capabilities, they can see through the dusty cocoons that shelter forming protostars to other galaxies like Andromeda, which is more metal-rich, and see how stars form in a very different environment from that of our own Milky Way galaxy. It is quite interesting to see the opinions of the astronomers in relation to the insights that Webb will provide towards the end of the stellar life cycle, when stars become bloated, red, and dusty. NASA's Spitzer Space Telescope showed us that dusty, evolved stars exist even in very primitive galaxies where they weren't expected. And now, through the use of Webb, they will be able to characterize them and learn how the models of the star cycle lines up with real observations. The instrument, of course, will be utilized to garner a large range of information for use in the astronomy field. It will also be used to look at the early universe via the local neighborhood. It will be used to resolve and study individual stars so that persons will be able to get an understanding of the bigger picture of how galaxies are formed and how they function. Astronomers then can ask even bigger questions of how galaxies have evolved over time and space, from the distant early universe to the local group, which is a collection of more than 20 nearby galaxies to which our galaxy belongs. It is also believed that even though this observing program will be looking locally, there is evidence of the early universe to be discovered. We will have Webb study a nearby ultra-faint dwarf galaxy, which is a remnant of the first seed galaxies to form in the universe, some of which eventually merged to form larger galaxies like the Milky Way galaxy. At great distances, these types of galaxies are too faint for even Webb to see directly, but small local dwarf galaxies will show us what they were like billions of years ago. They really need to understand the local universe in order to understand all of the universe. The local group of galaxies are a sort of laboratory where we can study galaxies in detail, every single component. In distant galaxies, we can't resolve much detail, so we don't know exactly what's going on in those galaxies. A major step towards understanding distant or early galaxies is to study this collection of galaxies that are within our reach. As the Webb mission progresses, their expectation is that astronomers will use the tools their team develops in unexpected ways. They emphasize that developing the program was an effort of the entire local universe astronomy community, and they plan to continue that collaboration once the data starts coming in. The observation program team plans to host a workshop to go over the results of the program with other astronomers and tweak the software that they have developed, all with the goal of assisting members of the astronomy community in applying for time to use Webb for their own research. This is really important, the idea of collaborating to achieve huge scientific results, as opposed to a lot of us trying to compete in a race to see who can achieve these results first or do them best. Like, comment, share, and subscribe. Thanks for watching, and leave your comments down below and let me know what you think about the amazing James Webb Space Telescope that will be launched by NASA soon. Take care and goodbye.